name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivered of subject Microcontroller for Embedded System, Hamming code KEC 061, what we have covered? We have covered the basic operations of the PCA timer. In the previous lecture, we have seen what is PCA, what are the various registers associated with the PCA, what are the different modes of operation, and each mode of operation, how it is associated with the particular module. So, in our unit number first of subject Microcontroller for Embedded System, we have covered up to a PCA timer. So, we will seen in the previous lecture, we have seen that there are three modes of operation of PCA timer. We will let's have a look. So, in the previous lecture, we have covered one of the operational modes of PCA timer, that is, just a minute. So, in the previous lecture, we have covered one of the operational modes of PCA timer counter, that is PCA timer counter capture mode. In the previous lecture, we have seen what is capture mode, how the capture occurs, and it occurs when there is a comparison or match in between the PCA 16-bit timer registers, that is CH and CL, and in between the CCAP, M, NH and L registers. Okay. So, in this lecture, we will study the two modes of operation, that is Pwm Generation Mode and high speed output toggle mode. We will see in this lecture, and in another portion we will see the embedded C programming for all operational modes. So, there are three modes: capture mode, Pwm mode and high speed output toggle mode. So, we will see the algorithm through some sample coding, how the capture occurs, how the Pwm mode occurs, and when toggle occurs, basically high speed output toggle mode, we can say that. Okay. So, these are the table of contents we will cover in this lecture. So, Pwm generation mode. Pwm represents, as the name implies, pulse width modulation, Pwm generation modes. This is one of the operational modes of PCA timer or counter. So, pulse width modulator mode is used to generate a continuous square wave with an arbitrary duty cycle. So, there are two terms here. It is used to generate a continuous square wave. Continuous square wave means it did not have any break, or we can say that it works on the continuous manner. So, it is basically used to generate a square wave with an arbitrary duty cycle. So, duty cycle means it may have a 75% duty cycle, 50% duty cycle. So, what is meaning by duty cycle? Let us have a look. Duty cycle is basically, we can say, it is equals to the T on divided by the total time into 100. So, if we can say there is a 50% duty cycle, then the on time and the off time is same. If we can say there is a 75% duty cycle, then the output will be like this. Okay. So, pulse width modulator is basically used to generate a continuous square wave with an arbitrary duty cycle. So, it generates 8-bit PWM by comparing the low byte of the PCA timer with the low byte of the compare registers. In the previous lecture, we have seen the match or comparison occurs when in between the two registers, that is CH, CL and the CCAP. So, we are comparing the PCA timer with the low byte of the compare register. So, when CL, that is PCA timer low byte, is having a value less than the CCAP NL, the output will be low. So, we can say that our output remains low until CL equals to the CCAP NL. So, output will low when CL is less than the CCAP NL value. When CL is greater than or equals to the CCAP NL value, the output is high. So, output only high when the value of the CL is greater than or equals to the CCAP NL. Okay. So, we can say that in this manner the waveform will generate it. It will make transition in the rising edge or falling edge. In the previous lecture we have seen. So, in this way the waveform will be generated. So, to activate this mode, to activate the Pwm generation mode, the user must set the Pwm and ECOM bits in the module. In the previous lecture we have seen what is CCAP MN module. M represents the particular mode operation. It may be a PWM mode, it may be a high speed output toggle mode, and M may be works on the PWM mode. And small n vary from 0 to 4. So, there are 5 mode of operations in our PCA timer. So, basically PWM ECOM bits, the value of PWM ECOM bits should be 1 if we are going to work in the PWM generation modes. So, to activate this mode, the user must set the set means PWM has have a value 1 and ECOM have a value 1. So, PWM mode should be 1 and ECOM means enable comparison, because we are comparing the things, we are comparing the values in between two registers. So, this ECOM should be 1, this should be set, and when they are set in the CCAP register, we can say that we are working in the PWM generation mode. Okay. So, this is the functional block diagram of PCA pulse width modulator in which mode? PWM mode. PWM mode. Okay. Just okay. So, here we can say that let us start with the CCAP MN register. We have seen what is the what n small n represents and what capital M represents. So, basically CCAP means capture, compare, module, mode register. Okay, and n vary from 0 to 4. 0 means module 0 and module 3 means module 3 and 4 means module 4. So, each module associated with the CX pin, output pin, we have seen in our previous lectures. Okay. So, basically this is 8-bit register. In the previous lecture we have seen that 7th pin, that is pin number, we can say pin number 8, last pin, MSP side. This pin will not used, it has some user programmable values. Okay. So, out of 8 bits only 7 will be used. Okay. And we are working on the PW mode. So, we are working on the PW mode, then PWM should be set, that is it should have a value 1. Okay. And ECCF Fn, it should be 0. Why it should be 0? Because we are not enabling the overflow interrupt, it should be reset, it should have value 0. Okay. And toggle, we are not toggling the values, we are only works on the PWM mode. So, this should also be 0, and no match occurs in between two, only we are comparing the CL with the CCAP NL. So, this should also be 0, and we are not working in the positive and the rising edge, because no toggle occurs, we are only deal with the PWM mode. So, this should also be reset, means it should also have a 0 value. So, what we have left? We have left with the PWM and ECOM. So, these should be 1. So, what will be the value? We can say first one is MSP side, it is 0, we did not have any value, 0, 1, 0, 0. Okay. After that this is 0, 0, 1, 0, 0, 0, 1, 0. So, what will be the value? 8, 4, 2, 1, 4 and 8, 4, 2, 42. So, it has a value of 42. So, it has a value of 42. So, CCAPMN have a value of 42. Okay. So, when this will be enabled, when it has a value 1, 1, this will enable the 8-bit comparator. So, the value of 1, 1 is sent into this, and this is the AND gate. The AND gate only works when both the bits are 1. So, when this is 1, this is 1, this value is going into the input of the AND gate and will generate the output 1, and this 1 will enable the 8-bit comparator. So, all the comparison only occurs when there is a overflow interrupt, and when overflow occurs, when the value of the ECOM and the PWM is 1, both the value have 1. Okay. So, when this is enabled, what we are doing? We are doing the comparison in between the CL. We have seen the principle of the PWM mode, it occurs only when we are comparing the CL with the CCAP-NL. So, we are comparing the CL and the CCAP-NL. Okay. So, there is a concept of overflow. We have seen in the previous lecture that overflow occurs. Overflow means the maximum value of 8-bit, because they are 8-bit register, they are counting from the 00 to FF. Okay. FF is the maximum value of the PCA timer. Okay. So, when FF exceed, for example, we can say that if we are adding +1 with the FF, the output will be 100H. So this one extra bit, 9th bit we can say, this is carry bit. So during PCA time operation, if there is carry occurs, then this overflow flag we have seen in the C that it is 1. So it represents that overflow interrupt only occurs when there is a when the maximum value rolls over from FF to further 0, when we have a overflow occurs. Okay. So when overflow occurs, this value will again associated with the CCAP N0, and in the previous diagram we have seen that when we are comparing the CL with the CCAP NL, the output is high. So we are getting the output high by using this. Okay. So when this will enable, okay, we can get the output in the high mode, and to remain control the duty cycle operations, we are comparing CL with the CCAP NL. When this is less, CL is less as compared to the CCAP NL, we can say that we are in the low mode. The output is low. The output associated with the CX pin is low. When until we can say until CL equals with the CCAP NL. Okay. So when it is equals or greater than with the CCAP NL, the output will occur and it remains during its maximum value. Okay. So we can say it like that. 0, we are starting from here, and the value, this value depends upon the CCAP NL. Okay. So when we are comparing this, we are getting the value here. Okay, and this is associated with the CXN. So through this we can say that PCA will work on the pulse width modulator mode. Okay. Okay, I hope you are getting the things. So in PWM generation mode, we have seen that the frequency of the output, because to trigger any IC chip, we need clock pulses. So basically each clock pulses have some associated clock frequency. So in PWM mode, we also need some frequency of operation. The frequency of the output depend on the source of the PCA timer. We have seen in the previous lecture that we 1/4 of the clock frequency, 1/12. So in PWM mode, the frequency of the output depend on the source of the PCA timer, obviously. So since there is only one set of CH and CL register, because for each module there is only one set of operation, it may be either a CH and it may a CL and CH. So all modules share the PCA timer and frequency. So for each particular mode, we have seen that there are 5 modules 0 to 4. So each module share only one set of CH and CL registers. The frequency is fixed to 256 count. How it is 256? Because it has a 8-bit value and we are counting from 0 to 255. Because it is 2 ki power x minus 1. So we are counting from 0 to maximum value 255. So for each PCA timer, it is the maximum, the frequency is fixed to 256 count. And the duty cycle of the output is controlled by the value loaded into the high byte. Okay. So what will be the value of the CCAP NH? It is decided by the high byte. It is decided by the its duty cycle. Okay, we will see with some example. Okay, so since writes to the CCAP NH register are asynchronous, a new value written to the high byte will not be shifted into the CCAP NH for comparison until the next period of the output when CL rolls over from 255 to 0. What this particular para represents? This represents when we are generating the output. The maximum value, it goes from 0 to 255. Here the value is represents the value of the CCAP NH. So when it rolls over from 255 to 00, when it rolls over from the maximum value, so we can say that when the next transition will occur. Okay, and the percentage of the on or off, it depends upon the duty cycle value. We will see with some example. We will. So to calculate the values, because in Pwm generation mode, we need to calculate the CCAP NH value under which it will work. It is equals to the 256 multiplied with the 1 minus duty cycle. Okay, this is the formula to calculate the CCAP NH. Okay, so where CCAP NH is an 8-bit integer and duty cycle is a fraction. Okay, let's study with the some example. Okay. So let's take duty cycle value is 75%. Let's take 75% duty cycle. Okay. So, we are going to calculate the CCAP NH. So, what will be the CCAP NH value for a duty cycle of 75%? It is equals to CCAP NH, it is equals to 256, okay, 1 minus duty cycle have value of 75%, means 75 upon 100, okay. So, it is equals to 256, 1 minus 3 upon 4, okay. So, 256 into 4 minus 1, 4 minus 3, 1 upon 4. So, it has value of 256 divided by 4. What will be the value? 256 divided by 4. I am writing here 256 divided by 4 for a 75% duty cycle. Okay. So, it is equals to 4824, 1 and 4 for the 16. It has a values of 84. Okay. Sorry, here it is 6, 4, 6, 24. The value of, so this 64-bit value is in decimal number, 64 in decimal number, okay, 64 in decimal number, and we need to convert in the hexadecimal because we are because microprocessor is working on the only in the hexadecimal word. So, we need to convert 6410 in decimal into the hexadecimal. So, what will be the value? What will be the value? 40. Okay. So, what will be the value of the CCAP NH? The value of CCAP NH is 64 in the decimal and 40 in the hexadecimal. So, to work the PCA timer in the PWM generation mode, we need to calculate the value of the CCAP NH. If we are able to calculate the value of the CCAP NH, we can say that we can go with the PWM generation mode. Okay, this slide is clear to you. So, in previous slide we have seen that PWM works on some particular frequency. How we can say the frequency will be calculated? Frequency will depend upon the PCA timer mode frequency. We can say that if PCA timer mode has a it equals to the 1/12 of the oscillator frequency, PWM will work on the two particular frequency 12 megahertz and 16 megahertz. If it has 1/4 of the oscillator frequency, it will work on the 11.8 kilohertz and 50.6 kilohertz. If timer 0 overflow occurs, that is 8-bit, 16-bit or 8-bit auto reload features, it works on this particular set of frequency in 12 megahertz of operation, and PWM frequency is 16 hertz for it has particular set of value if timer 0 overflow occurs. If I have external input, then the maximum value of the PWM frequency is 5.9 kilohertz, and in and here it is 7.8 kilohertz. So, we can say that PWM frequency it is equals to the F oscillator frequency into F oscillator frequency divided by 256. So, through this particular table we are going to provide the frequency to the PCA timer or counter. Okay. So, let us have a study, let us have a detailed overview of PWM mode through some coding. Let us start with the coding in PWM mode. Okay. So, what we will learn in PWM mode, we will see through some coding in C language. Okay. So, in this coding, these for starting first two rows, this represent the header file. This represents the header file. So, include stdio.h. Basically, stdio.h it means that external, we are talking about the external input output operation. SST89X55, basically this is the advanced architecture. We are talking about the 89, 50 LP, 51 RD2 to microcontroller operation. That is the advanced architecture of 8051. And void main, we are going to start here the C coding. C mode have value, 02. That means 0, 0, 0, 0 and 0, 0, 2, basically 1, 0. Okay. So, C mode value have a 0, 2. In our previous lecture, we have seen what is C mode and how it can be calculated. So, in the PWM mode, it has a value of 0, 2. And CL and CH represents the start of the operation, start of the PCA timer, and CL should be equals to 0, 0 because we are going to start the PCA timer in the PWM mode. So, initial value is 0, 0. Similarly, CH has a initial value of 0, 0. After that, what is the value of the CCAP 0L and CCAP 0H? We have calculated that for a 75% duty cycle, duty cycle, the value of CCAP 0H, what will be the value? 0 means we are going to work in the module 0. It may be CCAP 4H for module 4, and it may be CCAP we can say 2H for module 2 mode. So, the value of CCAP is 40x. In our previous slide, we have calculated the value of CCAP, that is for a 75% duty cycle, the value of CCAPH is 64 in decimal, and for hexadecimal, when we are converting into the hexadecimal, the value of CCAPH is 40 in hexadecimal mode. Okay. So both the values they should be equal, CCAP 0L and CCAP 0H, the value of it's 40, okay, in hexadecimal. Okay, in hexadecimal. We have calculated for a 75% duty cycle, the value calculated through 75% duty cycle. So, we can say for a 50% duty cycle, the value may vary for a CCAP 0H and CCAP 0L. Okay. So, these are the values. And what is this CCAP MN0? We have seen in our previous lecture that CCAP MN, it has some associated registers value, and we are going to work the PCA in the PWM mode. So, the PWM mode, the value of CCAP M is 042. Because we are set some registers value. If we are setting for a PWM mode, we are getting the value 42. In the previous slide, we have seen how we can calculate the value 42 through this one. Just a second. I am going to here calculate the value of 42. Here, through here, we are calculating the value of CCAT, because in PWM mode operation, the ECOM bits and the PWM bits both have value 1, and they are 1, we are getting the value of 42. Okay. This will help in our programming. Okay. So, it has a value of 42 and CR should be 1. Why this one? We are going to start the timer, and CR value should be 1. It should be set, because when this is set, we are going to initialize the timer operations. So, while means that what we are going to generate the mode, it will remain, it will go in the infinite loop. We are whatever we are calculating here, this will remain continuous while represents. So, this is the C language programming of PCA in PWM mode of operation. But we will left with the high speed output toggle mode. Let us start with. So, this is one of the operational modes of PCA timer or counter, high speed output toggle mode. High speed output toggle mode, toggle means 1 to 0 transition or 0 to 1. So, in this mode of operation, the CX means counter external enable, X may be from we can say X may vary from 0 to 4. So, we can say that if CEX is 1, so it is associated with the module 1 operation. So, in this mode, CX output pin on port 1 will toggle every time there is a match occurs between PCA counter. In the previous lecture or slide, we have seen that when there is a match and when there is a comparison in between the PCA counter CH and CL, when we are comparing the CH and CL with the CCAP, AP, NH and CCAP, NL. Okay. So, when we are comparing these things, when a match occurs, then we can say that it will toggle every time. So, when we are in the high value, it will toggle to the 0 low value, or from low to 0 only when there is a match occurs between the PC counter registers and the CCAP NH and CCAP NL registers. So, to activate this mode, to activate the high speed output toggle mode, user must set tog mat, it should be 1, tog mat ECOM values in the CCAP NL MN register, SFR register. We have seen in the previous slide that in CCAP MN there is some particular bits, the value of the toggle. Why it should be 1? Because we are toggling the value, we are toggling from the 1 to 0, 0 to 1. So, it should be 1, we are matching the values, it should be 1, and we are comparing the value. So, ECOM is enable communication, it should be 1. So, all these values should be 1. So, high speed output mode is much more accurate than software pin toggling, since the toggle occurs between branching to an interrupt. So, high speed toggle mode is more efficient as compared to the others. So, in this case, interrupt latency will not affect, there is no effect of the interrupt latency in case of high speed output toggle mode. The next toggle will occur only when there is a PCA timer rolls over. When PCA timer rolls over from the FF value to the 0 value, match will occur. So we will see through some figure. Here we can say that we are setting the value ecom mat tog, it should be 1. Okay. So when we are enabling CCAP-MN, it will, how it will enable? It will enable through CCAP-NH and CCAP-NL. So when this is enabled, it will enable the 16-bit comparator, and the comparison occurs in between the CH and CL and CCAP NH and CCAP NL register. When there is a match, for say that we are matching the from the we are counting from the 0 to FF in CH and CL, and if there is a match occurs, then it will again enable, it will toggle the output pin. Okay. So when match occurs, or when, how this will activated, how this will hardware will be activated, this will activated by the mat. Mat means it should be 1/4 to enable this hardware. So when this will enable, it will enable the CCF, this is the second register, it will enable the CCF bit in the second register. When this will activated, it will enable the PC interrupt, and when the PC interrupt, how PC interrupt occurs? It occurs when this is 1. So ECCF means enable counter control flag. So when this is 1, it will enable the PCA interrupt. Okay, the interrupt will be activated. Okay. So toggle occurs when there is a match occurs, and we can say that we are going to generate a high speed output toggle mode from this one. We are generating the waveform, and it is associated with the CX output pin. This is the operation of the PCA code. So let us study its C coding, C mode of operation. This is the C coding, this is the header files, this and CCF should be 0 because we are initialize the its values, and 30 is the value of the CCAP HS because we are enabling the tog match, etc. We are getting the value of CCAP 0H is 030. So C mode value is 002 because we are working on the high speed output toggle mode. CL and we are initializing the CL and CH. So CL and CH should be 00. We are initializing the timer. So what will be the value of CCAP? It is FF because it is counting from the its maximum value, that is FF. So when it rolls over from FF, the their interrupt will be generated. So CCAP-MN have a value of 40. In if we are we can see that in a CCAP-MN register, the value of we can calculate the value 40. Here it is 4C. It is correct. I am correcting here. It is 4C. Okay. So we are enabling it, that is C0, and CR should be 1 to enable the counter. So we are left with the PCA capture mode programming. Here these are the header values. We are going to some operations. We are going to initialize the flags. If flag is equals to 0, we can say that capturing only occurs when there is a capturing occurs only when there is a match between the register's value, and it occurs on the positive edge and it occurs on the falling edge. So how we can say that in falling edge or rising edge, the value of CCA pin should be 1, that is CCAP and CCAN, it should be 1. So when it is equals to 1 flag will generate, and we can say that capturing starts here, and we are calculating we are capturing the data during this, and the CCA pin has further values of 2 1 because we are going to calculate the pulse width at capture 2 minus capture 1 because we are generating the 2 waveform. Okay. So the value of particular flag is 0 because we are rolls over from the maximum value to the minimum value. Okay. So these are the C programming. So thank you everyone. I hope you have enjoyed my lecture. Today lecture we have learned about the C programming techniques. So in our next lecture I am going to start the AVR register, that is the topping remaining with the unit first. Thank you everyone.